Hello and welcome. Today we're going to be doing a lab for relays and controls. So you've just completed your module for relays and controls, and now we're going to actually have some components in front of you so you can see what they look like, make reference to the notes that are in your module. But we're actually doing your relays and controls lab. So have your notes with you. What I want you to do first of all is to be able to reference each one of these two relays. These are two different types of relays. I just want to show you basically shape and size of two examples of relays that we have here in the lab. So they're not very big units compared to in your module, for example, on page 6, make that page 4. Figure 3 just shows you a couple different examples of relays. Your relays can be bigger than this, it can be smaller than this. We're just going to use these ones here as an example of their functionality and all that. Now to start your lab, what I want you to do is to have a look at your exercise number 1. On page 3, and you're going to see a chart there between two different types of relays, which I have here in front of me. One of them is labeled a 248 and the other one is labeled 1208. Okay, 248 and 1208. So on each one of these you will have your coil voltage ratings, contact voltage ratings for AC, contact voltage DC, contact resistive rating, and contact general purpose current rating. Typically you get that information on both of these on the front panel. This manufacturer has all the information here on the front panel, located in white. So you should have some images that you can refer to in Blackboard that have these specific drawings. One of them for the 248, the other one for the 1208. Okay. Based on that, I just want to show you that each one of these are both 8-pin configuration. So there are 8 pins on the bottom of these, and typically a relay will be plugged into a base unit. So this one here just happens to be this blue plastic component that's attached to this silver box here, the metal box. And you'll notice that on the base of these relays, there is a notch in the center black portion. That center notch that's there matches up with your relay base, the notch that's there, and it ensures that they basically fit one way in, where I've lined up the notch in the center black portion of my coil to the notch that is in my base unit. Okay, so this manufacturer, when you purchase the base and the relays, they cannot be put in the wrong configuration. It just won't fit. There's only one configuration where they do fit and press together. So I just want to make you aware of that. All right. So the values that you see in your chart number 1, you're going to get from your images that have been sent to you. The next page of your lab shows you a diagram that is very similar to in your module on page 6, figure 4, where it gives you an indication of the terminal connections for your relay coil and your armature, your normally open contacts, your normally closed contacts, your return spring. All that is actually housed inside here. So if I had to show you, I'm just going to show you, for example, your 248 relay here. On the inside you'll see the tightly wound copper wire that would represent your coil, and let me just see here on this side here, you'll see the armature in the middle, and it's actually making contact with, I believe it's on your left hand side, to a normally closed contact, and from the armature in the middle to the right, it is open on that side. That would be your normally open contact. So your normally open contact is over on this side, and your normally closed contact is right there. And the same thing with your 1208. Kind of hard to show here. Oh, here we go. We have the coil indicated by 120 volts AC, and you will notice over here we have the armature coming down the middle, okay, and the armature is making contact this side. So from the armature making contact to here, this would be your normally closed side, and from your armature to this side would represent your normally open contact, and that's physically inside. And it's also the other set of contacts, because there are two sets of armatures and contacts. That would be the other side of your relay. Okay, so I just want to show you all that. Physically, your relay coil return spring is in there as well. Okay, all your internal components. All right, so I just want to make you aware of all that. It's important that you label your diagram in your lab booklet to signify what are the terminations of these 8 pins, which ones connect to your relay coil, and again make reference to your drawing there, and the little square symbol in the middle, right above where it says bottom view, the little square symbol, that represents your coil, and the 2 terminals that connect to your coil are connections number 2 and 7. 2 on one side, 7 on the other. Okay, and then your armature is represented in the middle, where you will see, for example, on the left side, termination number 1 represents 1 armature connection, so it's your common connection. And from 1 to 4 represents normally closed, and number 1 to number 3 would represent a normally open contact. So if I came off lead number 3 to a load from number 1, that would be normally open. And again, same on the other side, on the right side, 8 is the common connection of my armature. 5 would represent normally closed. 6 would represent normally open. Okay, so hopefully you were able to see that. Just want to show you that. So make sure you label in your lab booklet all the specific terminations. What I'm going to show you now is I'm going to use a 1208 relay coil, and this one, the relay coil is rated for 120 volts. So we're going to plug this guy here into our base. There we go. I'm going to put the other relay coil that's rated for just 24 volts on the relay, on the coil portion aside. We're using the 120 volt coil for this first part here. I have in my possession what's called a variac, a variable output voltage, and we're going to be sending a variable voltage, or we're going to increase voltage going to our coil here, just to see at what point the coil creates enough magnetism to pull the armature in. All right, so this one here, it is rated for 120 volts. So I'm going to take my variac and plug it into my power supply, and then I'm going to take the output of my variable voltage power supply and connect. First of all, I'm going to connect my bond connection. Now I want to verify the 2 connections of my relay coil that represent just that, the relay coil. So if you look on your coil, the termination points for my coil are points 2 and 7. So I'm going to take my line voltage connected to, I've got some of my leads here labeled, termination number 2, and I'm going to put my identified over to termination number 7. Now what I'm going to do, just to show us, and hopefully you can see this, I'm going to be using my voltmeter, and I'm going to set it to AC volts here, and we're actually going to measure the voltage coming out of the Variac and see at what point my coil creates enough magnetism to kick in my armature. Okay, so what you're going to hear is some vibrating, some buzzing sound. That's the whole process of creating enough magnetism to try to pull the armature in, and the armature is trying to get pulled into the core portion of the coil, and at one point the vibration will stop, and basically now there's enough magnetism and it just pulled the armature into the coil. All right, so I'm going to try to have a look at this. And so here right now we are measuring AC voltage. Okay, and I've got my Variac turned on and start producing a little bit of voltage. You see the voltage is increasing ever so slowly. Just gonna move this a little bit closer to you.